Our AP level question, we have two parents have each built a toy catapult for use in a game at an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapult so that the balls land within a 5-centimeter band. A target line will be drawn through the middle of the band as shown in the figure below. All points on the target line are equidistant from the launching location. If a ball lands within the shaded band, the student will win a prize. The parents have constructed the two catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult and measure the distance that the ball travels before landing. Distances to the nearest centimeter are graphed in the dot plots below. Now, question A. A wants us to comment on any similarities and any differences in the two distributions of distances traveled by balls launched from Catapult A and Catapult B. For this, we will be using comparative SOCS. If you don't know what SOCS are, BAM! Those are SOCS. But in all seriousness, SOCS stands for shape. Shape can be normally distributed, skewed, or uniform. Our O stands for outliers. Outliers are the same thing as anomalies that are like away from the norm. C stands for center, which can either be your median or your mean, depending on if your graph is skewed or normally distributed. And your last S stands for spread. Now, depending on your center, your spread will either be a 5-number summary or your spread will be your standard deviation. Now, using SOCS, we want to compare these two dot plots. So there's Catapult A and Catapult B. So to do comparative SOCS, we're going to start with shape. The shape for Catapult A is skewed right. The shape for Catapult B is normally distributed. For outliers, Catapult A has outliers at 155 and 110, whereas Catapult B doesn't have any outliers. And the other outlier at approximately 121. The median for Catapult A is at 136. Unlike Catapult B, whose mean is 138.6 centimeters. Catapult A has a 5-number summary of a minimum at 121 centimeters, the first quartile at 133.5 centimeters, a median at 136 centimeters, the third quartile at 138 centimeters, and a maximum of 155 centimeters. Compared to Catapult B, whose standard deviation is approximately 2.5. That is how we use SOCS for letter A. Now letter B, it's asking us if the parents want to maximize the probability of having the ping pong balls land within the band, which one of the two catapults, A or B, would be better to use than the other. Justify your choice. I believe that Catapult B would be a better choice because it is normally distributed, unlike Catapult A, where the ping pong balls land in various spaces and are skewed. There are many outliers in Catapult A, whereas Catapult B, most of your ping pong balls land in the same area. With Catapult B, you have a better chance of getting all your ping pong balls in the same area. Question C asks, using the catapult that you chose in Part B, how many centimeters from the target line should this catapult be placed? Explain why you chose this distance. I believe that the catapult should be placed 138 centimeters from the target line, since that is the mean of this catapult and it's closer to the center, so most of your balls would be targeted in this one area. Now is the final question for comparative SOCS.